So today we're going to be wrapping up EE9. So for the past 2 days, we have talked about coordinate planes. We've talked about independent and dependent variables. Today what we're going to look at is taking your input, output, or function table, whatever you want to call that, same thing. We're going to take that and we're going to actually apply it to word problems. And we're going to talk about how we can use these from equations and graph them and make our own equations from the table. So let's take a look at our first one, which is going to talk about, and I'll read you the story. It says, Henry records how many days he rides his bike and how far he rides each day or each week. He rides the same distance each time. He rode 18 miles in 3 days. So that's where we have 18 miles, 3 days. He rode in 24 miles in 4 days, 42 miles in 7 days. It says, write and solve an equation to find how far he rides in 10 days. So what we're going to do is we're going to complete this table by saying, first of all, it said 24 miles in 4 days. So we have 4 days, we're going to put 24 miles. In 7 days, he rode 42 miles. And we want to find out the 10. So what we need to do is figure out what type of equation we're actually looking at to figure out 10 days. So I need to know, what can I do to days to get to miles? Okay, so basically we're saying here's days, we're going to do something to it, it's going to equal miles. Now, what can I do to 3 to get to 18? There's a lot of things. I could add 15 and that would be fine, but it's got to work on all of them. So if you said 4 plus 15, you're going to get 19. That says 24, so that doesn't work. What else can I do to get to 18? What about simple multiplication? So 3 times 6 is 18. So let's check it and see. 4 times 6 is 24. 7 times 6 is 42. So you could say days times 6. So you could say 6D equals M. So if I do 6D equals M and I substitute in 10 for D, we're going to do 10 times 6 and we get 60. So now that we have that, what we can do is we can put it on a graph. All right, so in this graph, we can say that, remember, our D in this problem is going to be our independent because the amount of miles is going to depend on how many days we ride, okay? So this is going to be our X and this is going to be our Y. So our days is going to represent our X-axis. The M is going to represent our Y-axis. So we're going to go use that as order pairs. We're going to go right 3, 1, 2, 3. Up 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It's going to be somewhere up here. It ran off the screen, and that's okay. Now, we would probably pick other numbers, too, that we could go down. We could even do 1 day. If we wanted to go back and do 1 day, we could say, well, if we went 1 day and you said times 6, that would be 6 miles. So watch what happens. So we're going to go over 1. We're going to go up 6. 1, 2, 3, 4, 5, 6. If we did 2 days, and that's 6 miles per day, that's going to be 12. So we would go right 2, up 12. There's 6, 7, 8, 9, 10, 11, 12. Now, we have our linear equation as a steady, constant rate up, okay? So now let's look at, let's see. Let's pull up this one. All right, so on this one right here, we're looking at our X and Y. Remember, these can be, these are independent dependents. These are also ordered pairs. Now we have to figure out what is the equation that goes with this. So while ago, our equation was 6D equals M, because we were saying the days times 6 is the amount of miles that we're going to go total. This one's a little bit different. So I will tell you, starting with 1 can be a little bit confusing because you can do anything you want to 1. And it's not going to really help us with the others. So let's look at 2. So in here, we could say 2 times 2 times 2 to get to 4, and that would work. But the problem is what you do to this 2 to get to 4, you're going to have to do to 3 to get to 9. And 3 times 2 is not 9. 3 times 2 is 6. So that rule is not going to work. All right, so let's erase that one. And let's try, how else can I get to 4? Well, let's do 2 times 2. Then I could do 3 times 3. Then 4 times 4. 16. Now, does anybody else notice a pattern here? Okay, so let's look at this pattern. The pattern is 2 times 2, 3 times 3, 4 times 4, which in previous lessons we understand that that right there is where we're talking about squares. We're talking about exponents. So we could also call this 2 squared, 3 squared, 4 squared. So now where we put in 2, 3, and 4, we can also enter in an x for that variable. So we could also say x squared equals y. Okay, so what that means is everything on this top row, this x, we could plug in for x here and say 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5, or 5 squared, is 25. All right, so remember, when it comes to function tables or input-output charts, all you have to do is find that function rule to make sure that it makes sense. Remember your independent and dependent. Your dependent always depends on your independent.